Hey everyone, welcome back to our channel. We used to talk a lot about AI getting bigger and more powerful, but what if it gets smarter and more efficient? Like instead of just teaching computers to think like brain, we started building computers that actually think like brain. So that's the ideology about neuromorphic computing. And today we are here to help you to understand what the concept is about. I'm Achna and this is Divya, Sabresh and Surya here to explain you in detail about neuromorphic computing. Hey Divya, so what is neuromorphic computing and what is the fundamental problem it solves?
Great question, Archana. Neuromorphic computing is nothing but it is an engineering approach where it builds chips which is inspired from the function and structures of a human brain. So it mainly solves two problems. Firstly, every computer has one human bottleneck where processor and the memory are placed separately. So each time the processor fetch the data from the memory, which requires lots of time and waste of memory. So neuromorphic chips overcome this problem by combining both memory as well as the processor in a same place. So the second main problem is training a large AI model requires a lot of energy, which is equals to a small town, which aims the AI model more energy efficient, which leads to greener AI.
It was a very good explanation about it. So if Sabresh, if it not acts like a normal chip, how does it actually process information? Like what is the secret sauce behind it?
The secret behind this spiking neural network or SNN. And we can take an example for a laptop. In laptop, the chip is always running, whether it's on or off. It's not a matter. It's always running. So in this neuromorphic chip is opposite to that. If whether it's any connection or spike is receiving, it will activate. If not, it will not activate. We've also seen an example with a person sitting in a dark room. If anyone coming under flicking a light, the person will react. Otherwise, he will not react because it's sitting alone and it's dark. So that's a main example for that.
It was really insightful information about the spiking neural networks. So it's over to Surya. Like the question for you is, what are the real world applications? Like if we are not able to use it in smartwatches, and give me the applications in detail.
Okay, so this is the really exciting part about this because of the whole, the way it automates and they makes things easier for us. So this is the most exciting aspect of this. Since it's everywhere, this has a versatile range of applications, and since it's everywhere, you can treat this as like a medicine or something for the problems which occurs in your laptops, PCs, etc. So the applications range from difficult situations like in medical and in robotics. In advanced robotics, since it combines the memory and space, it's really useful in advanced robotics. And the main aspect about using this as an application is that you need specialized engineers in this concept. So not everyone can go and do this neuromorphic thing. You need people who are actually capable of understanding a machine so well, so that they can implement and integrate both the memory and space to its best use. The application are like large. It's present everywhere. We must be able to see it, and once we can see its application and once we can utilize its use, we can make sure this neuromorphic technology is solving everyone's problem and everything is made easier in the future.
Thank you, Surya. So we got to know about the different aspects of neuromorphic computing. Like Divya gave us the introduction about what it is, and he gave us about the special secret sauce in it, like about the spiking neural networks. And Surya said about the real world applications. So that's it about neuromorphic computing. If you have any queries, drop a comment. Do like, share and subscribe here in our AI. Thank you.